Hello everyone, I'm Vishesh Vaibhav, your Google Developer Student Club student. Welcome to another video on linear regression. Now this is one of many videos in this series where we'll talk about regression. So this is the first starting point where we'll start talking about a very important topic called regression. Now if this is the first time you're hearing about regression, it's totally fine because we are going to talk a lot more about it in the future. But there are a few prerequisites before starting up. Firstly, you should know what is data preprocessing because we'll be implementing a linear regression model from scratch. But if we are going to do that, you should know what data preprocessing is. Second, you should know Python because everything that we are going to do is in it is going to be in Python. So Python is definitely a prerequisite. Now, before starting out, I just want to say that if you have watched our previous videos, then well and good. And if you haven't, I seriously suggest you to go to our YouTube channel and watch our previous videos. Now, before starting out, if you are a part of our boot camp, this topic was already covered in our offline class. Now, if for some reason you could not attend it, that's totally fine because now we are going to do that from ground up and understand it step by step. But before attending our next class, you should be able to understand these concepts in order to proceed. All right. Now, with that said and done, if you are not part of the boot camp, well, definitely you do not need to listen to all of that. You can just start learning normally, and we'll do that by just starting out with some theory, and then we'll jump on to the practical. So, what is regression? So, before moving on to actually visualizing things and learning things, let us understand what is regression. Well, in machine learning has three types of learning experiences. First is supervised, second is unsupervised, and third is reinforcement learning. Supervised learning is when you give the machine learning model the input as well as the output, and then the machine learning model is trained on it in order to give you a prediction. Whereas in unsupervised learning, you only give the inputs and the machine learning model uses some algorithms, some unsupervised algorithms where we can get the predictions from. Whereas reinforcement learning is when we use the concept of rewards and punishments in order to make the model learn about these predictions and actually, make something out of it, which is reinforcement learning. We reinforce the model to make some predictions. Now, uh, before starting out, the main topic, which is regression, there is one thing that you should know. Well, regression is definitely a topic which you will study in statistics. Well, statistics is definitely based on formula. So nothing is magic. Same goes for artificial intelligence. While we are doing regression, which is a statistical technique, all of the things that we are going to predict is not magic. The machine learning model also does it through some sort of formula, which we are going to derive today in this at the end of the video. So if you attended our offline class, and if you're watching this, I seriously suggest you to go to the last part and see what actual formula did we use in order to achieve this. So that is something that I would seriously suggest. All right. Now, when that is said and done, let us jump on to the theory part and let's start. All right. So now that we are here, let us start. All right. So the first thing that we need to understand is regression. So in order to do that, let me tell you what regression actually means. So regression is nothing but a statistical technique which allows us. Let me check if it's recording. Yes, everything is all right. All right. So, regression is a statistical technique which allows us to know a relationship between dependent variables and a series of independent variables. So, if you remember from our previous lecture, we talked about a term called dependent variable and independent variable. If you are new to this, I seriously recommend you go back and watch that video. Now, dependent variable is something which we are predicting, and independent variable is on which the dependent variable makes the predictions from. So, for example, in this case, if X is the number of hours a student studies and y is the marks that the student gets, then this would mean that if the student studies for 10 hours, he's scoring 80. If he's studying for 20, then 100, and so on and so forth. Now here we have one independent variable, which is the number of hours the student studies, and one dependent variable, which is the number of marks he's scoring. But if for some reason we were to add um, a new column which says mood, right? If we were to categorize the mood into some numbers like 1.5, 2.5, something like that. So this would be another independent variable which contributes to the prediction of y, that is marks. So here we have a series of independent variables which contributes to the prediction of one dependent variable, which is the number of marks the student is scoring. All right. Okay. So I hope that is clear to you what I mean by independent and dependent variable. Now, in this case, this is what it means. So the regression model is something which tells us the relationship between x and y, or the relationship between a dependent variable and an independent variable. Well, how does it do that? That is what regression is. Now, it uses some formula and everything, which are we are also going to do. So, the formula which regression mainly uses is y hat is equals to b1 plus b0, sorry, b0 plus b1 x1. Now, if we were to know what all of this is, well, this is the dependent variable, what we are going to predict. B0 is the constant, or we also call it the intercept. B1 here is the slope coefficient. Sorry about that. And x1 here is the independent variable. If none of this makes sense to you, I'm going to put some sense into it. All right. So let us, as we talked about, it's a part of a supervised learning. Now let us jump on to a part of regression, which is simple linear regression. Now, as I talked to you about regression, I must not have mentioned that there are many types of regression: simple linear regression, multiple linear regression, polynomial regression, SVR, random forest, and many more. But we are going to go step by step, and firstly there is simple linear regression. Now the theory part here, there is only one dependent variable and one independent variable. So I hope you know what that means. So if there were more independent variables, then it would be a part of multiple linear regression, not simple linear regression. So if you have any data which has one independent variable and one dependent variable, or if there is only one data which affects the dependent variable, then it is a simple linear regression. It is suitable for a simple linear regression model. All right. So what we are going to do right now is we are going to visualize something called potatoes yielded based on fertilizer. So for example, if we are taking a graph here, okay, and let us call this X and let us call this Y, okay, and this would be X kgs and Y tons. Okay, the tons would be a different spelling, but it's okay, just for the space purpose. Now we have this. The x would be what we are, the independent variable. So in this case, what is the independent variable? Pause the video and tell me. Exactly. The independent variable here would be the fertilizer, because that is what we are going to use to predict the potatoes yielded. So here it would be fertilizer, and this would definitely be potato. Sounds good? Okay. So based on X kgs of fertilizer, how many tons of potato we are getting? So I'm a farmer and I did some, calculation. So for example, I bought 2 kgs of potato, 2 kgs of fertilizer, and I put it into my farm. And for with that, I got, for example, for 2 kgs of fertilizer, I got 15 kgs of potato, right? So for 2 kgs of fertilizer, I got 15 kgs of 15 kgs of potato, right? Okay, sounds good. Now, the reason why I'm telling you is this, because in regression models, usually we use a different type of graph, which is called a a scatter plot, right? So you have heard about bar graph and you've heard about things. So if we were to do a bar graph, this would have looked something like this, right? This would have been 2 and this would have been 15. So if this was a normal bar graph. So how scatter plot is different? So what scatter plot basically means is that if 2 kgs of fertilizer is used and 15 kgs of potato, what we are getting, then we'll give a point here. All right. And then based on some other data, for example, if we are using 3 kgs, then we are getting, for example, 15, right? It depends. And based on that, we are going to I'm a farmer, so I did my calculations, and based on that, I'm going to mark this scatter plot. So here, 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 here. All right. Now that is done. So we do not need this because in scatter plot, we do not use this kind of notation. It is understood that if this, what this line means, this dot means that the data should be somewhat here. All right. Okay. Now this is what a normal data looks like. So for X kgs of fertilizer, I am getting Y tons of potato. Now, my farmer minds thinks that I want to predict that if I am using, for example, 1,000 kgs of potato, what am I getting? Right? What am I going to get? That is what I want to predict. Now, how do I do that with using this? Now, let's go back to the formula that we were using. The dependent variable, which is the potato. So, potato and the constant will be B0 and B1, which will be the slope coefficient, and X1, which is the independent variable, right? So, the constant and the slope coefficient is what we calculate, right? So, for example, if we are getting 8 tons of potato by yielding 3 tons of fertilizer, and if we put it in this formula, then we would be getting some value, right? That we'll be getting some value for the dependent variable, which is the potato. But we are not looking to do that right now. Definitely, that is what the machine learning model does for us. We do not need to do it manually, right? But how regression comes here, how what are we predicting? So the prediction part is what machine learning does. We cannot do that. We can definitely do that, but it would be cumbersome to do it alone and do such big calculations, though although this is a very small data. But if it's a very big data, why to do it alone and why to do it by yourself, right? That is why we use these models. Now what regression does is it draws a line, right? It draws a line. Now it has drawn a line because it wants to predict. So this is a prediction line. Now it has predicted something. Now what has it predicted? It has predicted the yield, the potato yield based on some fertilizer, right? So this has some points. Now this can have many lines, but for example, it can have this, it can have this, it can have this. The regression model can predict anything. But how do we know that which is the best line? How do we know that how does the regression model know that I want to predict this line? Now, mind you that this line is what the regression model is predicting. This is not what I am doing, right? So for that, the regression model uses a technique called ordinary least squares. I'm going to write that for you. Ordinary least squares. So this is what a technique that the machine learning model uses to predict. Okay. I'm going to draw a graph here for us so that we understand that what is happening. All right. Let me just see if this is okay. Okay. So I'm going to draw a graph here and I'm going to do it right here so that it's all okay. Okay. So the ordinary least squares, what does it mean? We're going to understand everything. So I'm going to draw the same thing here, or it would be better if I just, all right, I'm going to draw it again. All right. So the thing is, these are the different scatter plots that I got from This is again going to be y, this is going to be x. Now I'm going to draw a line here. Now this is what the line gave me, that this is what the prediction gave me. But how does the prediction work? How do we know that if this is really working? Now we can have multiple lines here and there, and I'm not going to draw multiple lines, but this is just for your visualization. Now the thing is, we have these dots, these for example, I'm going to paint it yellow. No, yellow won't work. Let me paint it green. All right, so these green dots are the actual values that were predicted by the farmer, right? And the black line is what is given to us by whom? Well, the model, the prediction model, right? Now, all of this can draw a line here, right? Now, this is the actual value, and this line is the predicted value. And this is never going to be perfect, mind you, because see, the prediction can never be pitch perfect. This line can never go through like this. It can never do that, right? It is always going to predict some value, and we need to know which value is the best value. Now, the predicted value is called yi. Well, let me just change that. All right. So the predicted value is called yi, and the original value is called yi, and the predicted value is called yi hat, right? So this is how it ordinary least squares work. So the difference between yi and yi hat is called residual. Okay, this is called residual, and this is given by this. So this is called the residual. Now, we why we call it ordinary least squares is because we do this thing that I have done, drew lines. This is just for visualization purposes. We're going to do that for every other line. So if we had a line here, we're going to do that for every other line with and match with the actual values that we are getting. Now that is going to give us the actual values, and we have our predicted values. Now the best equation, this equation that we just had here, the best equation is where the sum of yi minus yi hat square is the least. That is when this is what ordinary least squares means. So the best equation is where we have the least value of the sum of the residual. That is called ordinary least squares. So I hope you understood that part. And I took some time explaining this because this is a very important thing that you need to understand in the theory model. Because once you understand this, you're going to go ahead and do the theory part really easily. Now this was done, and mind you, this is only for one dependent variable and one independent variable. So this is what it was. Now let us jump on to our our laptops, fire up our laptops, and let us start with some practical work. So I'm gonna do that just that right now. All right. So there are two things that we'll be using here. All right. So the first thing is we'll be using our data pre-processing toolkit that we did in our previous video. So if you do not have this, you can just go back and find this in our previous video description. And we are going to create a new Google Colab notebook, and we are going to call it simple linear regression. All right. This is what it was. Now we are going to implement this from scratch. So I need your full concentration here so that we can implement this from scratch and do this really easily. Now we have understood some concepts which will be really important for us to proceed. But first of all, the data set that we are going to use is already attached in the description box. So the first thing that this is allocating runtime. So the first thing that we are going to do is we are going to import the data onto a Google Colab notebook. And if you are coming back to this data preprocessing toolkit, you might not find that data, that same CSV file here, because it always gets reset. So if you were to run this, we would get an error because this won't work. The data is not imported. All right, we're going to come back here and we're going to upload a file, the linear regression. Let me check if this is, yeah, this is what we are going to use, and I'm going to upload it. So this would you would find this data set into your in your in the description box. I'm going to rename it so it does not has any. All right. So this is how we are going to start. I'm going to add a section where we are going to use data pre-processing first. Now, see, this toolkit that we have is going to be used for most of our projects, and we are going to do the same. So the first was importing the library. So we're just going to do that. We are going to import the library. So I am just writing. Okay, let me do that. So it's better here. It's importing the libraries. So yes, we are going to use NumPy, we're going to use pandas, and we are also going to use matplotlib. So we're just gonna import that, all right? Because these are some libraries which we are definitely going to use. Now, once we have done that, what was the next step in the data processing toolkit? Importing the data set. Then obviously we're gonna do that. So I'm gonna copy this. And before copying, I'm just going to create another section which will be saying importing the data set. All right, let me do that. Okay, I'm going to paste it here, and obviously the path would be different. So I'm going to copy the path and I'm going to paste the path here. Now let us visualize the data first. So we have years of experience data and we have salary. So what it generally means is that for 1.1 years of experience, the salary is this much. For 1.2, this much, and 3.7, this much. Now what it wants us to do is we want to predict, and it has many more. So it has till here. So it has 30 entries to be precise, right? So I want you to pause the video and tell me in this what will be the independent variable, right? Because we definitely want an independent variable here. So what would be the independent variable? Definitely the independent variable would be years of experience, and the dependent variable which we are going to predict is going to be the salary, right? So I'm going to delete this because we did this and this was for the previous data. And although this would be the same, you can write it. This would be years of experience, which is the independent variable. I'm going to write it independent variable, and this was for the dependent variable. All right. So now we have that, and I hope you understand what this means. So I'm not going to explain it again because we have done that in the previous video. So I'm just going to run this, and this will be valid for almost everything because this the dependent variable is almost the last column in every data set. So this is valid for everything. So I'm just going to print x and print y just like we did before. Print x and print y. All right, we're getting that. We're getting there. Now we might notice some like missing values here. So you might say that, okay, is this a missing value like we did in the previous data preprocessing toolkit video? No, this is not a missing value. This is actually zero. So if you look at it, it's 2.0, 3.0. It's actually zero. So it's not showing up here, but it's totally fine. We do not need that. And this is also 0, 0.0, 0.0. Okay, all right. Now you've done that. Let's move on to the next step, taking care of missing data. So we're just gonna visualize the data set again. Now, usually if you have a very large data set, you should always go for that. You cannot visualize it manually and check if it has a missing data or not. But usually it's a good step to do it. But because it's only 30 entries, we're gonna do that and check if it has any missing data. We do not have any NaNs, which is, and we do not have any not numbers, which means we do not have any missing data. So this is not important. Now encoding categorical data. Now I want you to remember the last data set that we had. It had some string values, and remember we talked about why string values needs to be converted into integer values for the machine learning model to understand it. But here if you look at it, we do not have any string data. So it is integer values only. So do we need to do encoding categorical data? I do not think so. because we do not have any yes no's values, we do not have any, you know, string values. So this step is redundant. We're going to come to the next part, which is splitting the data set into training set and test set. We're definitely going to do this because this is important. This would be done regardless of what we are going to do, right? So let me just add a section here, which will be called split the data set into training set and test set. All right. And I'm just going to copy all of this because it's all the same. So I'm just going to paste this. And this means 20% of the all the data would be reserved for the test set. All right. Okay. We're going to print X train and X test just like the previous thing. X test, print Y train, and print Y test. Now, I did not explain what the previous line of code meant because we have done that in the previous video. So I seriously recommend you go ahead and learn all of that and come back so you know what is happening. Okay, now this seems good. What's the next step? Feature scaling. Now, do we need to do feature scaling? Are we comparing anything? I don't think so because feature scaling needs to be done when the value is not comparable. So like we had this value here, this does not need to be compared. We do not need to compare anything. So feature scaling is redundant. And like that, we complete a part of data pre-processing. Now we are going to jump on to the training part where we are going to train the simple linear regression model on the training set because that is what we are going to do, right? So I'm going to close this and I'm also going to close this. Now for that, let us check. I'm going to do it from the ground up. So I'm just going to ask you. Remember how we did that in the previous classes that we did? How did we know that okay, if we want to train a simple linear regression model, which library to import? Because I have no idea which library to import right now. How do we do that? Well, which sklearn library is used for training simple regression model? All right. This is a simply learn. I'm going to go to the official documentation. Okay. This is what we need. So it's sklearn.linear model. So this is what we need. Okay. From sklearn dot what are we going to import? Linear regression. Linear regression. All right. Sounds good. Now we imported a class. What do we need to create? An object. Definitely. You have definitely learned what we did. So we are going to create an object there. Okay. And we're going to keep this in mind. We created an object and linear regression. All right, let's check if this takes any parameters. Where it should give us something. All right. So if we need the copy X, none, Boolean values. All right, so a mishap happened while I was making the previous video. I had made the full video and then I was checking it out, and the part after this was missing. So I have to record it again, but it's okay. I do not mind. So let's do that now. All right, so I was checking if if it was taking any parameters or arguments. Well, it's taking some fit intercept, copy. It's taking a Boolean values to be precise, right? And if I come back here, I don't think we need to give it any parameters. So we are not giving it any parameters. The next thing that we need to do here is, one second, let me check if it's all working. Yes. All. So the next thing that we need to do here is we need to take a look at the methods that we have. So what are the different methods that we can uh, give to this regressor object? So we have all of this, but what we are looking what we are trying to do right now is we need to train the model. So let me just add a section here. We are training the simple regression model on the training set. Training the simple regression model on the training set. Right. This is what we are doing right now. All right. So for training, what we need to do is we need to fit the data, our X train and Y train, into this training set or into this object. So how do we do that? We use the fit method, right? This is what we use. Let me check if it's working. Okay. We use the fit method. So fit takes X and Y. So if it's taking X and Y, let us give it fit, sorry. It's taking X and Y. Let us give it X and Y, which will be X train and Y train. All right. Anything else? It's sample weight. We are not giving it any sample weight because that is not necessary right now. And we're going to run this. And again, you give us this linear regression. Now, this is totally fine. This is what you get when the model is trained on the regressive model is trained on the simple regression model. So it's a linear regression. So it's trained on that. The object is trained on that. So now everything that we are going to do right now is on this regressor object. All right, what's the next thing? We have trained the simple regression model on the training set. Now let us check if it's actually working. So we are going to create a ypred a variable, and then we are going to use another method of the object, which is predict. So it's take x as an input and gives us the predicted value of y. So what was the x? It takes independent variable as an input and gives us the dependent variable as an output. So let us do that. Regressor.predict, and then we are going to give it x. So in this case, we are going to give it x test. All right, we're going to give it x test, and let's see what it gives us. So to get that, we're going to hit x y pred. We're going to print that, obviously. So we're getting something like this. Now, what does this value mean? So we're going to scroll up and see what X test was for us. So it's 5.3. So for 5.3 years of experience, the person should get this amount of salary. For 7.1, the person should get this amount, and so on and so forth. So this is working. Our linear regression model that we just trained is working. It's a good news, right? Because it's working. Yes. Now that as it's working, let us dive back into the theory and let's check what we did, right? I'm not going to go back in theory and explain you everything, but I need you to go back into the video and check what we did. So we need to visualize the test set results now. First, we need to visualize the training set results, and then we need to visualize the test set results. So I'm just going to create um, visualize the training set results first. All right. So how are we going to visualize this? Well, it's simple. We are going to visualize it with the help of matplotlib because that is the library that we had imported, and we're going to use that. So if you remember, I told you back in theory for regression models we use a graph called scatterplot. So that is what we are going to use. Plt dot scatter. The spelling should be this. All right. What does it take? Well, it takes x and y. So we're going to give it x train and y train because firstly we need to visualize. Let me just write it first. And then we need to give it any colors. Yes, we need to give it any colors. Okay. All right. So we have used the plt.scatter to get the x train and y train. And what's the next thing that we need to do? We are visualizing the training set results first, but let us first understand that what was the original value. So if you dive back into the theory, you'll be understanding that, okay, if we were using X kgs of fertilizer, we were getting Y kgs, Y tons of potatoes, right? We did that. Now we're going to use the same example to understand the scatter plot in our case. So for X years of experience, Y amount of salary should the person be getting. All right. So that is what we are going to do. PLT.scatter, and then we are going to do one more thing, but not now. And then we are going to give it a title in a string. So if you are using this for the first time, it's totally fine. With experience, you are going to learn all of this. Salary versus experience, training set. We're going to give it an X label, and we are going to give it a Y label. The X label would be the independent variable, which means years of experience. And this would be salary. And then we are going to use BLT dot show to actually show that. All right, there should be color. All right. Now, what have we got? Now, this is the original value of X train and Y train. Now, if you look at it, if you have this many years of experience, that is almost 2.1 or something like that, you should be getting around 40,000. If you have around 4 years of experience, you should be getting around 60,000. Now this was the original value of X train and Y train. Now remember why we split the data into X train and Y train. The data was a whole, but we took some of the data and used it as in training set, and used some of the data and put it into test set. We trained our model on the training set, and the test set has no information whatsoever about our trained model. It has no information. It has no information about a method called linear regression. It does not. Now we'll come back to what we are doing. And we are, remember what we did? We drew a line in between of our predicted line and checked if our predicted line is, accurate or not. Now, there is no way we are going to get a line which matches all of the points here. There is no way we can do that. So, because it cannot be totally perfect. So, what we are going to do is we're going to write another line here, which will be plot. So, a plot is a line. So what we are, let me check if it's working. It's working. PLT dot plot. So what we are plotting here, we are plotting the X train, and then we are going to give the predicted model now. So how do we do that? Well, we have done that above as well. X train. By this, I'll tell you. Color is will be, let's give us a different color, blue maybe. All right. Now this line means that we are plotting a X train line on the, we are plotting it on the X train line, and then what we are doing is we are predicting the value of X train. Now we are giving it X train. So what will it give us? It will give us a value of salaries, right? So X train was what? X train was, let us check what X train was. X train was years of experience. So for this years of experience, how much salary should I get? So this is what this means actually. So if I were to run this, let us see what I'm getting. All right. So I am getting a line now. So this is, if you see, this line is the predicted line. This is what this means. This is the predicted line. Now this predicted line is giving us the predicted values, comparing it to the original set of values, right? So for this amount of experience, this is what our predicted line gives us. Okay, sounds good. Now, the thing is that it is giving us the predicted value, and we are using it on the training set now. Now, what if we were to do this on a test set? And mind you that this is a completely working model now, because if we are using a regressor or predict, the model is working. It's giving us a value of y X train. So for 9.5 years of experience. How much money should I earn? Well, it's right here. This is what it's giving us, and it's pretty close. So, because it was trained on the training set, and because we are predicting the training set, it's giving us an almost accurate value. See, the lines almost match each other, which means this is a good prediction. But we are now going to test it with our test set. All right, we are going to visualize our test set. All right, let's do that now. The test set. So I'm going to copy everything from the above cell, and I'm going to give it X train and Y train. Sorry, so this is the test set, right? So we are going to give it X test and Y test. So this would be the same because we have trained it on the X training data, so this would definitely be the same. And now if I were to show this, then this is what I would get. Now let me just do this by removing this line first, and I let you visualize the data without the the predicted value. So this is the actual value of the X test and Y test. So for this years of experience, I am getting this much of salary. Sounds good. This was the training. This was the test set. So this was the test set. So this is what we did it, gave it. Now this model has no experience about our simple linear regression that we just did here. It has no information about it, right? If it does not have any information, that means it is a test set. And now if we were to put a line here which says plt dot plot and x train, so we are plotting it on the x train part, and we are predicting the value of the x train, and for that we'll be getting a bunch of salaries. So let us do this. So this same line worked really well for the training set because it was trained on the training set. Now this is also working well on the test set. That means that it is almost close, not perfect, but it's good. So which means that our model is now working. Now we have a working model which gives us a value of the test set, a value of the salary based on some years of experience. Now this is what we are getting on the basis of a CSV file that we put in. So for this year's experience, this was this. So now what if I want a prediction for a years of experience which is not mentioned in this? How to do that, right? Because it might happen that I have built this model. I want to predict something which is out of scope for this model because the most years of experience we it had is 10. What if I want to predict a salary for some person who had 20 years of experience? How do I do that? Well, it's easy. So what we are going to do right now is we are going to print, and remember we have a method with us now. It is predict. So if we give us, first let me write it, regressor dot predict. Now if we were to give, it takes x as input. Now x is what? The independent variable. So it takes independent variable as an input and gives us a dependent variable as an output. Right? It sounds good. So how do we provide this now? Because it's a simple, we are giving it a single value to predict. So if we want to predict a single value, this is what we, single value prediction. So if we want to predict a single value for the salary, then how do we do that? Because I want to do the prediction for 20 years of experience. So if I were to just write 20 and just give it, this would give me an error because it is expecting a 2D array. So if you look at this, all of this is an array. So, and if you look at it, I'll tell you why. So this is a 2D array, because what we are giving is just a number. So this is not good. So in Python, if you remember, we create array like this. So now if I run this, this should work, but this won't work. Why? Because we are giving it in one-dimensional array, not a two-dimensional array. How do we create a two-dimensional array? The answer is right here. So if you look at all the x train and y x test that we are getting, it is enclosed in two brackets. The first bracket starts here, ends here, and then the value is definitely again in a normal square brackets. So this is what we have to do. We need to give it, for making this value a two-dimensional array, we need to enclose it in two square brackets. And now if we just run this, we would be getting a value. So for 20 years of experience, the salary that the person should be getting is this much, right? Sounds fair. Now I have all of that, and now this model is able to predict what I want to predict. But how does this model work? I mean, is it magic? No, it's not magic. This is purely statistical, right? Then how do we do it? Well, it's quite simple. So let us understand the formula of the model. All right. All right. We're going to understand the formula of the model. So I just need you to go back to the theory part. And we did a formula when we were first studying regression. Okay. The formula was y hat is equals to b0 plus b1 x1, where y hat was the dependent variable is equals to b0, which was the intercept or the constant, and we were adding it to the b1, which was the slope coefficient, and the x1, which was the independent variable. Now, once you first looked at it, you might not be getting anything that what is coefficient and intercept. Now, we're going to understand it right now. Okay. So slope coefficient is the value of the slope coefficient. So the slope value is that. Okay. And the constant is which stays constant, and because of which we are getting that value. So if I were to jump into the more statistical part, that would be getting a bit more complex, which we are not going to do right now. But what we are going to do is we are going to get the value of coefficient and intercept in order to get a formula for ourselves, so we can check if this is working. Okay. All right. So if we were to come back here, let us check if there is any method which gives us the coefficient value of coefficient and intercept. Well, we have a coefficient here and we have an intercept here. All right, so we do have that. So if we were to print regressor, which is our object that we created up here, and we were to print the coefficient, then this should give us the value of coefficient. But we need one more thing, coefficient. Okay. But we need one more thing. We need the intercept. It was the same? Yes, it was the same. Okay. And what is this? This is the constant or the intercept. Now we have got a value of both for both of them. Uh, Coefficient is 9332.944 and this value, and the intercept is this value. Now to get the formula, right, we are going to put the same formula into what we studied earlier. Okay. So first comes y0, which is the dependent variable. So how did we, uh, what do we induce from, what did we deduce from all of this? Okay, the dependent variable is salary. So we're going to give the salary here. And then comes the part where we write b0. So what was b0? B0 was nothing but the intercept or the constant, right? Scroll back of the video, you'll get what I mean. So the intercept here was 25609. All right. And then what we are going to do is we are going to uh, plus the coefficient, and which was coefficient which was b1 into x1. So b1 into x1, which means 9332 into x1. X1 was the independent variable, which is years of experience. So years of, all right. So this is our formula. I'm going to write it like this. Okay. So this is our formula now. So to get the salary, we have our intercept or the constant, which we are multiplying, which we are adding to the multiplication of these two. And with that, this is how this regression model, simple linear regression model works. And the subsequent videos, we'll be understanding multiple linear regression and a lot more things. But this should be your first stepping stone into the world of regression. Now, once you have understood this, we're going to proceed further. So, thank you so much for watching this video, and thank you. Meet you in the next video.